Continuing on with probability, if we have two events which are not influenced by each other, they're called independent events. And here we have Luca and Hannah doing two things. Luca's playing darts and Hannah's swimming in a pool. If we call event A Luca scoring a bullseye and event B Hannah swims 50 meters in under 30 seconds, the probability of A might be 0.45 and the probability of B might be 0.72. If Luca gets a bullseye, that in no way will influence how fast Hannah swims, and likewise the other direction. So the probability of A given B is still 0.45. It doesn't matter that B occurred. A is always 0.45, and therefore it's the same as probability of A. And probability of B given A will still be 0.72 because A occurring has no effect on B. So probability of B given A is the same as probability of B, and it follows from that for independent events, the probability of A and B occurring, using our multiplication rule from before, is really just probability of A times probability of B. And this is true as long as A and B are independent. So let's do a couple of examples here. So we have Luca and Hannah here. We have our probabilities from the example. Find the probability that Luca scores a bullseye and Hannah is going to swim under 30 seconds. So we are looking for the probability of A and B occurring. So these are independent events. We just have to multiply the individual probabilities. 0.45 times 0.72, and we get 0.034. Three significant figures, remember. B, find the probability that exactly one of these events happens. So what's that going to be? Well, it's going to be the probability that A occurs and B doesn't. That's exactly one event. Or union, A doesn't occur and B does. So these are disjoint events here. A intersect B prime, A prime intersect B. We don't have to worry about subtracting at the end. Probability of A intersect B prime, well, that's just going to be a multiplication. These are still independent of each other. We have 0.45 times 1 minus 0.72 plus not A occurring, so 1 minus 0.45 times 0.72, and this probability ends up being 0.522. Three significant digits again. For this example, we have two independent events, A and B. Probability of B is 0.4 and A union B is 0.75. We want to find the probability of A. Well, we know the probability of A union B from our earlier work can be found by taking the probability of A plus the probability of B minus the probability of A intersect B. And we don't know that A and B are disjoint events. We don't know that they're mutually exclusive, so we do need this minus at the end. But we do know that they're independent. So what can we split this up as? We can split this up as probability of A times probability of B. Let's plug in our numbers at the same time. 0.75 equals probability of A plus 0.4 minus the probability of A times 0.4, the probability of B. And we can combine our like terms, collect things together. We get 0.35 equals 0.6 times the probability of A. Dividing both sides by 0.6, we get that the probability of A is 0.583. Now find the probability of A intersect B prime. Well, if A and B are independent, A and B prime also must be independent. So to find this, we need to take the probability of A and multiply by the probability of B prime. Well, we have that information now. We're going to take 0.583 and we're going to multiply by 1 minus 0.4, and we get a probability of 0.233. Remember, if you ever do end up with a probability greater than 1, you've probably made a mistake. Either that or the thing you're trying to find is actually not possible to have happen. Our last and final example has to do with going on safari and taking pictures of cheetahs. So we have Makia going on a photo safari. The probability that she takes a photo of a cheetah on any given day is 0.3. Find how many days the safari must last so that the probability that Makia takes at least one photo will exceed 95%. She really wants a photo of a cheetah. Anytime you see the phrase at least one of something, think that that's going to be the same thing as 1 minus the probability of none. In other words, 1 minus the probability that she gets no photos whatsoever. So 1 minus, well, what's the probability that she doesn't get a picture on one day? Well, that's 0.7. But we don't know how many days it's going to be. So 1 minus 0.7 to the n. And we want that amount to be greater than or equal to 0.95, 95%. Now, how do we solve this? Well, we haven't gone through at this point in the course that we're in how to solve this algebraically. If we know how to use logarithms, this is a fairly straightforward solve. We can rearrange this and get 0.05 is less than or equal to 0.7 to the n, and we can evaluate this using a logarithm. If we don't have logarithms at our disposal, we probably have at least some technology to use. And we have two ways to use our technology. One way to do it, I'm going to insert a graph page. I'm going to find the intersection of 0.05 I need to rescale my axis. Let's go 0.1 on the y-axis, and I'll go down here. Let's go negative 0.1. A little bit easier to see what's happening. And now 0.7 to the n, I'm going to press tab. 0.7 raised to the x power. Oh no, where is it? Well, probably need to change our x-axis. Let's go out to 10 and see what we can see. Ah, there we go. 0.7 to the x is an exponential decay graph. If you want to see a little bit more of that, maybe go up to 5. Maybe that was a little too big. We can play around with our axes to get a good graph. There we go. And this horizontal line was f of x equals 0.05. And we want this point of intersection right here. So we're going to go into Menu, Analyze Graph, Intersection. If you're ever not sure what to do, go up here. It tells you how to do it. We only have two graphs, so we don't have to select them. We select our lower bound, our upper bound, and there's our point of intersection. So this means that after 8.4 days will be equal to 0.05. Well, we want to be at least this. We need to round up to 9 days. We're only talking whole number of days. Now, another way we can solve this is to open up a calculator page. And we could actually go all the way back to the 1 minus 0.7 to the n greater than or equal to 0.95. I'm going to press Menu and go to Algebra. I'm going to use numerical solve. 1 minus 0.7 raised to the nth power equals 0.95. And we put a comma and we tell it what to solve for. We once again get 8.4, but we want this side to be at least 0.95, so we would need to go up to 9 days. If this is a calculator exam, it's assumed that you probably are using technology to make that jump, and it's completely okay to use one of the two methods that we just saw. And that's where we shall stop for the day. And hopefully you see the connection between independent events and conditional probability.